Hi everyone, and welcome to the first video dealing with your spring break assignment. We're going to be looking at the first, what I think is the first set of problems on your packet. Why don't we get started with problem number one. Here is problem number one. In this one, you're given a graph, has the area, the region R right here, which is what you're going to be working with. And you're told that it's in the first quadrant. And it's being bounded by the graph of y equals 4 ln of 3 minus x, y equals 6, and x equals 2. This one is not a particularly difficult one in terms of what you have to do. You do have to be aware of the relationships that you need to set up your definite integrals. But this one would be one that is just really going through and working with the material that we covered at the beginning of chapter 7. So first thing we have to do is find the area. The area on this one, remember, it is going to be, you always want to go through and set it up. Remember to go through and deal with top minus the bottom. So it's not, you got to be aware of that, how y equals 6 fits into there. For letter B, we want to find the solid generated by revolving this around the horizontal line y equals 8. Well, remember that horizontal line is going to be somewhere up here. And so remember, you're gonna set this one up. You probably go through. I would just do this as a disk method problem, but remember your radius, your inside radius and outside radius on this one, because when you go through, you do have to determine your inside radius and outside radius. Remember to start from that axis of rotation and go towards the region. The first curve, the first boundary you come to is the inside radius. Second boundary would be the outside radius. So be aware of that. Disk method on this problem would probably be the easiest one to do. You do have the option of using the shells if you wanted to, but they will be expecting the disk method on this particular problem. For C, the region of the solid, R is the region of the base of a solid, and the cross-section is perpendicular to the x-axis is a square. Find the volume of the solid. So again, because you're going perpendicular to the x, you're going to integrate with respect to x. And really the key part on this one is going through and identifying and realizing that this line, that red line I just drew in, that would represent the side of one square. So you're going to want to go through and come up with an expression for that. And then remember, anytime you're finding a volume, when you do a volume, it is always going to be the integral of an area. So in this case, the area is of the cross-sectional face is a square. So we're looking at integrating the area of a square to find that volume. So that should be enough to get you through problem one. Now, problem two, we have a velocity vector of a particle moving in the xy plane, has the components that are listed here. dx dt is this, dy dt is that. And this goes for t going from 0 to 1.5. And they do tell us that the position of the particle at t equals 0 is at negative 2, 3. The thing that you have to look at here, first part is find all values of t at which the tangent to the path of the particle is vertical. All right, so remember, the tangent line, the slope of that tangent line is dy dx. So keep that in mind and use that to identify what would have to be true if you're going to have a vertical tangent line. And again, this is also a graphing problem, so you're going to want to go and graph that expression out and solve it using the graph instead of trying to do it by hand. Letter B, write an equation for the line tangent to the path of the particle at t equals 1. All right, so what you're going to have to do on that one. Number one, you're going to have to go through and find the slope of the tangent line, which you'll be able to do based on even what you're looking at from part A. And then the other part that you're going to have to do is identify where we're at. Remember, for part B, anytime you're going to find the equation of a line, you need a point and you need a slope. And then you can plug that into the point slope form of a line. Well, the slope you're going to get from identifying dy dx. The point is really you're going to have to keep in mind that at t equals 0, you're at negative 2, 3. And so you're going to have to identify the x coordinate and the y coordinate separately on this one. So use the information to find x and y, and then you can find the slope by plugging 1 in for t and identifying what that is. Also make sure your calculator as you go into this thing is in radian mode. C, find the speed of the particle at t equals 1. So what happens there for the speed, remember at t equals 1, that's going to be the magnitude of that velocity vector. So you're going to go through, identify what the velocity vector is for at t equals 1, and then you can go from there. And the next thing you have is the acceleration of that particle. Obviously, in terms of that one, you got your velocity vector is the components are given up above, and realizing the relationship between velocity and acceleration, that should give you enough information to go through and find the acceleration vector and then evaluating that at at t equals 1. Now looking at problem number 3. In this case, what they gave you on this one, you have this diagram here of a pool that's supposed to be a pool, that's a cylindrical pool, and you have this table of values, which is really looking at the rate at which which the water is being pumped into the pool, and that's at specific values here. So in this case, every 2 hours is what they're looking at. Now, you got some dimensions on the pool. The pool is 4 feet by 4 feet height, and it has a radius of 12 feet. So that's going to be something that's going to come into play as well. Then what happens on this one, we know that the pool contains 1,000 cubic feet of water at time t equals 0. So that's something else you're going to want to make sure that you recognize on there, because they don't give you that initial amount just because they have a reason there, and it's going to come into play in the problem. During the time interval from 0 to 12 hours, it's being pumped in P of T, and you got the table values. During the same time interval, water is leaking from the pool at a rate R of T cubic feet per hour, where R of T is equal to that function. And then they do go through and tell you to remember that the volume of a cylinder is pi r squared h. Now, the first thing they want you to do is use a midpoint sum with 3 subintervals of equal length to approximate the total amount of water that was pumped into the pool during that time interval from 0 to 12. Show the computation that lead to your answer. Okay, so you're supposed to use a midpoint sum. Okay, so, and they do have the 3 subintervals. So this one is where you can have, where mistakes can happen. Realize on here that the 1st, 3rd, 5th, and 7th markings are going to be the endpoints of your subinterval. The 2nd, the 4th, and the 6th are going to be the ones that you're going to use for your height. So keep that in mind as you're working on that, and then set it up. Now set up that the integral, or the use the midpoint sum to approximate that integral that you need to show how much water's come in. Then they go through in part B, calculate the total amount of water that's leaked out of that. This one right here, if I remember right, I think this one is still a calculator problem. So you can use your calculator to go through and do that. In fact, yes, it is a calculator problem. So you're going to want to go through on this one, just set up the integral that you need to answer it, and give your answer to 3 decimal places. For part C, use the results from part A and B to approximate the volume of the water in the pool after 12 hours. And they want you to round your answer to the nearest cubic foot. Okay. Keep in mind, you have to go through and recognize what the 2 integrals in A and B are telling you, and use the given information along with A and B to go through and find that total amount of water that's in that pool. Then the next thing they want you to do in there, part D, they want you to find the rate at which the volume of water in the pool is increasing at time t equals 8. How fast is the water level of the pool rising at t equals 8? Indicate units of measure. Okay, so this one's an interesting problem because of the fact that first you have to go through and determine how fast the water is increasing. So you have to identify at that point, at t equals 8, you have to find out what's happening with the volume. How is the volume changing? You need to find, so for part D here, the first thing you have to find is dV dt at t equals 8. Okay, so you have that. So that's, and keep in mind, that's not looking at the way the water's coming in, way the water's going out. It's looking at how the water level in the pool is changing at t equals 8. Okay, the next thing they want to know is they want you to find how the height of that how the height of the water in the pool, the depth of the pool is changing. Keep in mind, you know, as I told you up above in the problem, that V is equal to pi r squared h. And so you want to find, what they're asking you to do is find dH dt. Okay, so you have to find that using the information you have here, and this is at t equals 8. Okay, so that, and also again, make sure on this one here, this problem is one that you do have access to units. The volume is cubic feet on here because all of the measurements are in feet. So you're going to want to make sure for each one of these problems, whether they tell you to or not, make sure to go and indicate the units that are associated with that problem. Here we are on problem number 4. This one is one that really would be more along the lines of an A-B problem, in that you're just basically interpreting the graph on this one and using your knowledge of calculus and the meanings of derivatives and integrals to go through and answer questions based on this graph. Now, the first thing you have to recognize here is that this is the graph of V. So you want to keep that in mind. A squirrel is going to start at building A at time 0 and travels along a straight horizontal wire connected to building B. For t going from 0 to 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. At what time interval at what times in the interval, 0 to 18, if any, does the squirrel change direction? Give reason for your answer. Okay, again, this is your velocity, and you have to remember the difference between velocity and speed is velocity gives you a direction. Okay, so using that information, you should be able to come up with when the squirrel is changing direction and answer that. At part B, at what interval on the at what time in the interval from 0 to 18, again, is the squirrel farthest from the building A? In other words, what we're looking at here, now notice on this one here, we're looking at a closed interval. So therefore, you have to check, when they're talking about when is it farthest from building A, you've got to look at the critical values within the interval, but you also have to check the endpoints. Okay, so you have to keep that in mind. So, based on this, remember at t equals 0, the squirrel is at building A, so that obviously is not going to be when it's the furthest. And what's going to happen is you've got to calculate how far it is at the two endpoints, 0 to 18, as well as the critical values. And you've just got to identify those critical values based on this graph. Part C, find the total distance the squirrel travels during the time period from 0 to 18. Now this part is interesting because of the relationship you have here. Remember, and this goes for B and C, the difference between distance versus displacement. Okay, the distance is, the displacement is how far you've changed from your starting point. The distance is the total amount that you've actually traveled there. So keep that in mind as you're answering B and C. Okay, part B is a displacement where C is a distance. And then D, write an expression for the squirrel's acceleration, A of t, the velocity and distance x of t from the building that are valid on the interval from t equals 7, from t going from 7 to 10. All right, so on that one right there, 7 to 10 is really looking at this part right here. Okay, so they want an expression for the acceleration, A of t. They want an expression for V of t and x of t, that distance. So keep that in mind. Also, please keep in mind that when you find x of t on the interval from 7 to 10, okay, this x of t is position. It is not the displacement from t equals 7. So you got to keep that part in mind in terms of identifying your x of t, that the distance from building A at that from t equals 7 to t equals 10, what the expression you're going to use. So keep those in mind. Now we get to problem number 5. Problem number 5 is a combination of what's happening with in AB and BC calculus, in that you do have improper integrals taking place in this one, and you have limits to infinity, which would be AB as well, would be AB. Really what you have here, the first one, this one is kind of interesting because of the fact that you only have 2 parts. And the way it works out on this one is that you got the first part A is worth 5 points, and part B is worth 4 points of the 9. So that's how the breakup takes place. The first part is they want you to find the absolute maximum value of g of x on the interval from 0 to infinity, if that maximum exists, and then you have to find the minimum value, again, if that minimum exists, and you have to justify your answers. Okay, so looking at that, this is a classic problem right from early part of Calc 1. When you first really start working with derivatives, and would be something you would see just after you got the quotient rule. You do have to remember, in this case, you're working with function g, so that's that one. And so for part A on this one, you got to take the derivative of that and realize, and then find your critical values. Now, in this case, like I said, this one was worth 5 points. Well, you get 2 points for just doing the derivative, which means you get 2 points for doing the quotient rule correctly, and then 1 point for identifying the critical points. Now, critical points are going to occur when that derivative is 0 or undefined. So you always have to keep that in mind on this one, on a problem like this. In this case, just, you should be able to take a quick look here at 1 plus 4x squared and realize something about that. That's going to come into play in terms of your critical values. Okay. Then you get, then once you have your critical values, you have to remember that you're looking at from there, this is an open interval. So you're looking at relative max and mins. If they occur, they're going to occur at those critical values. We're not dealing with a closed interval, so you don't have endpoints to check. Okay, so you're not going to have to worry about that. You're looking for the absolute max, absolute min, if they exist, and then you do have to justify your answers on that one. So keep that part in mind. So remember, part A, you got quotient rule. Oops. Using that to find those critical values. In part B, find the area of the unbounded region in the first quadrant. First up, you do have to go through and determine, based on what you know on this one, and really, if you've once you've answered part A, the next part really is in terms of is setting up that definite integral. Which one is on top, which one is on the bottom. I would expect that you probably don't have two, that you can look at these two and determine that right away, that which one is on top, which one is on the bottom. So you want to set that up and realize in this case that you're going, when you set this one up, you got to realize that you are going from x equals 1. Okay. So you're going to be going basically in the it's the unbounded region in the first quadrant to the right of that vertical line, x equals 1. So basically your limits are going to go from 1 to infinity. So you're going to have to deal with that. And you're going to have to evaluate then that definite integral because you're looking at the area between the two curves. Okay, so and in that case, it's 4 points. You get 1 point for your integral, 2 points for the anti-differentiation, and 1 point for your answer. So that's kind of how those points break down. Realize the issue you're going to have in terms of that is going through and remembering it in terms of evaluating those. And remember, you got to take the antiderivative of each one of those. So that will come into play as well. Okay. Now for problem number 6, here we are. We're dealing with a Maclaurin series. The Maclaurin series that's been given to you right here is f of x. And it does on its interval of convergence that you have. First thing you have to do is you have to find the interval of convergence for that Maclaurin series, justify your answer. So that's just a pretty straightforward problem. We've done that a number of times in terms of identifying the interval of convergence for a problem. So really, you have to find that, or in this case, they want the okay. Yeah, they want that interval of convergence. So you're going to want to go through and make sure to do that. Please remember that you do have to check the endpoints. Don't forget when you're working, anytime you're working with an interval of convergence, that you do check the endpoints. So you have that. Now in part B, what you're going to want to do, you want to show y equals f of x as a solution to that differential equation. So what you're going to want to do is you're going to want to go through and do an expansion of this. Write out the first few terms and then remember that that's going to be added on. And then you're going to have to use that expansion to find y prime. Okay? Now be careful when you find your derivative. That's all I can really say on that one. Be careful when you find your derivative. I would go through on the expansion that you have when you first find y, when you do the expansion there, and you have y equals and you have your term. simplify those terms, make your life a little bit easier. Get those things simplified as much as you can. And then you can go ahead, take the derivative of those. And remember that you also need to deal with the derivative of this bad boy. Okay? That's where you're going to need to be careful on that one in terms of taking that derivative. And then what you're going to want to do on that is plug that information. So in part B, you're going to have y equals, and you're going to have a polynomial with that, and then plus that -1 to the n, 2x to the n over n minus 1. And that's just blotted out. It continues on. And then you're going to have an expression for y prime as well. And it's going to involve that, the derivative of that. And then what you're going to have to do is plug this stuff that you have here and here in for, you're going to have x times y prime. Well, you're going to have to take what you have for y prime here is going to go into that spot. And then minus y. So what you have for y up here is going in this spot. And you're going to want to you're going to want to simplify that. Okay. Key thing you have. Okay. Note what the numerator is right here. Okay. And when you do this, when you've gone through and simplified that, you're going to want to pull out a common factor. And that common factor that you're going to pull out is going to be 4x squared. So pull that out and then take a look at what the result is. Okay? Take a look at what that result is and think of that. Try to determine what series that is. What type of series that is. So that's really what I can tell you on this one. And then you can go through and you should be able to go and find those show that that f of x is a solution to that differential equation. So this does conclude that for the first set of hints that I can give you on these. Again, I want you to keep trying on these, see what you can do. And hopefully you are enjoying your break and at least getting some relaxation and getting ready for that final push here at the end of your senior year. So we'll see in a few days. I will go and put together another hints video dealing with the rest of the problems that you have, and I'll post that probably in the next couple days. We'll see. But with that, I will say goodbye, and again, we'll see you in a few days.